Today's my topic is decentralized computing. I think we have done couple of presentations before this around this area. I remember Hetu did one long time back about blockchain, and I remember Chamil did one called decentralized future. I mean, it's not like I went through the tech talk list, but I think those are the two we had in this area. Hope I haven't forgotten anything else. So in this tech talk, I thought of sharing with you some understanding I have got working in Hot Pocket, some conceptual understanding. So, I mean, I'm going to risk it. I mean, this might be a boring topic because it would be a bit skewed towards theoretical aspects or the conceptual aspects of decentralized computing rather than showing practical applications. So, giving you a practical real world understanding of it. But let's see if we can learn something out of it. Because I think a lot of people, including myself, I don't think we have a very good idea about what the hell is this blockchain and decentralized computing, smart contracts and all that. So I'm deliberately not going to get into this terminology game explaining all the terminologies used in this area. So I got this larger picture, which is the decentralized computing. So to talk about decentralized computing, you don't have to talk about blockchain, you don't have to talk about smart contracts. So this is more of a high level concept that's there in the computer science field. But it's only that people started hearing about this when the blockchain and the smart contracts and Bitcoin cryptocurrency came into the picture. So they are all, we can consider it like they are all implementations done using the decentralized computing concept. So this tech talk is about that concept, not about the actual technologies like Bitcoin or Ethereum or blockchain, any of those things. So I think I don't have to spend effort on explaining those terms, which I myself don't have a very good understanding of, even though I am working in the Hot Pocket project. Um, I think it's mostly because the lot of us has been like from this traditional computing background, which makes us think everything in terms of the traditional systems perspective. So I think that's what makes it hard for us to grasp some of these concepts really well. So this is another attempt at this, trying to make you guys understand some concepts. Okay. Right. So before talking about decentralized computing, so this might sound like a university lecture as well, but forgive me. Um so we have to look at the larger picture, which is distributed computing. So I'm pretty sure you have learned this as a course module. I mean, at least in some degree programs or optional subjects, you might have encountered this as a subject, distributed computing, right? So I think you already have awareness about this distributed computing, right? So basically, internet, networking, and everything we work with, they are mostly a part of this distributed computing. Now, decentralized computing is like a sub branch under distributed computing. Okay, so it goes on without saying. Uh, if there's something like decentralized computing, there should be the opposite, centralized computing. So centralized computing is the one which we are actually used to, even though we don't call it centralized computing. Okay. So this is the relationship between distributed and decentralized computing. Okay. So let's try to understand what is distributed computing. I mean, going back to your university basics. So in a simple term, they can be considered as systems which consist of many machines, right? We encounter a lot of such systems nowadays, and we also work in those systems, developing them. So, I mean, just to have some engagement with you guys, can any of you know, let us know examples of such systems? You can use your project work or your day-to-day uh, activities, online activities. I mean, you can come up with some answers. And I prefer if any of the new guys, like probably interns before they depart, we had some intern presentations today, or any of the new guys make an attempt to it, it would be even better. Because this is a very easy question. You would definitely know the answer. No one?
If no one is attentive, probably I can
Yes.
give an answer. I'm not sure whether this is correct. Ravin. Based on the project experience, I just thought of what about Azure functions, durable functions? Is it similar to this concept where you have complex tasks that you can run parallelly by different functions, and at the end of the execution cycle, it gathers the results and whatever the different nodes that's been return the results and collect the results and finally give the output. This is something that I just something that reminded me based on the Azure functions. Not sure whether it's correct.
Yeah, I think it's correct. I think it's a really really good matching even to explain the concepts also, which I didn't think of earlier. But so that's a very elaborate answer, which I think some people would not even understand what the hell is distributed. Sorry, durable functions. I think it's a very elaborate, serious answer. But thanks, Iran. But I am pretty sure uh, a lot of other people can come up with much simpler answer without having as much knowledge as Hiran or other experienced members in GVO. Any simple answers? By the way, can you see my screen now? I think I mistakenly switched it off. Can you see the
Yeah.
presentation? Okay.
I think browsing the web is distributed, right?
Yeah. Yes. So I mean, basically, I mean, when you hear that answer, you might realize nowadays every damn system we use is actually a distributed system. Okay, I mean, you can look at it from different perspectives. Uh, Now, Hiran's answer of you call that the Azure functions, durable functions. So it is a much clearer answer, which is even easier to explain theoretically. But actually, you are using all the network systems, which will fall into this distributed computing category. Okay. What is not distributed computing might be using MS Word to type a document, okay, because there's no network activity. So I think from the moment you have some network activity, that means you are basically on a distributed system because there are multiple machines talking to each other. I think as this simple icon diagram specifies, right? So please know that this is not a complicated thing. It's just a term, like serious sounding term, distributed computing. Okay. But decentralized computing, on the other hand, it can actually get a bit complicated to understand as well. Okay, there wouldn't be, I mean, I wouldn't be able to show you. This is a very good example of decentralized computing which you use day to day. Okay, so that's one problem in explaining this decentralized computing versus distributed computing. Okay, um, so we got some examples. So now let's look at the other sub branch we already know of, which is the centralized distributed computing. So any networking system, we can say it's distributed, but because several machines are distributed and they are talking to each other, but how do we classify the centralized versus decentralized? I don't think you guys think whether what I'm using, I know I'm using a network system, but is it a centralized system? I don't think that's where our understanding becomes less and less, right? But I can make it easy for you. Uh, I think nowadays almost 100% of the systems that you and I would be using, you and I would be developing except the Hot Pocket project, I mean, but I mean traditional software projects in GVO or even in Sri Lankan software companies, almost 100% they would be categorized as centralized systems. Okay, because they are so common, we don't call them as centralized systems. We simply call them IT systems. Okay, that's why you don't hear this term that often. So the nature of centralized computing is they use centralized decision making and coordination points. Now, Hiran might, or people who have used this durable functions would immediately recognize Hiran's answer of distributing the workload for different functions and then Hiran used the example of collecting the answers back and doing some coordination work. In fact, in durable functions, there is a actual function named coordinator function, right? Or like orchestrator function. Like I forget the terms. So that's why it was a really good, serious example. Now that's the nature of centralized systems. So they have these decision-making points, some single points of making decisions. So there has to be someone coordinating the work, even though there are many machines, there has to be a teacher or coordinator, like coordinating a classroom. You can't just let bunch of kids uh, put them into a room and just tell them to learn. So you have to put a teacher there to coordinate and have some discipline, teach them some rules, basically doing the coordinator's work. Okay. So let's look at some examples. Um, so if you look at a traditional web server system that we develop in GVO, so you would have a web server which is acting like the interface between the users and the system and the backend system, and you would have several subsystems like the database system, probably an email server, blob storage. The web server might store images in the blob storage, send some outgoing emails to the email server, and store the user records in the database, right? So this can also be considered as the coordinator. Basically, in this case, in this diagram at least, the web server is the coordinator, okay? Because it's actually coordinating the requests that are coming in and deciding based on the business logic, deciding what parts to send to the database, what parts to send to the blob storage, likewise, okay? So this is a single point of control, right? So this is a very simple example. Just please ask me if you have weird questions, okay? Sometimes when I explain, even to new members, when they are joining the Hot Pocket team, when I explain these stuff, they come up with weird questions that I also have to struggle to answer. But at the end, it enlightens everyone and it makes you think a little bit. So I mean, you can ask, I mean, is that centralized? I mean, why do you call this centralized, even though it doesn't seem like centralized? You can ask questions like that. So this is another example. So I mean, when I asked Asela when he joined, I think it was Asela. So when I asked him to like give an example of a decentralized system or some topic like that, he gave me a load balancer example. I think he was thinking it was decentralized because there are many servers serving, right? So when large systems with high request loads, you would have many servers handling the load, right? So the load would get distributed across many servers. So different servers would handle different loads. Okay. So large systems like Facebook, Google, Microsoft, all the services, they all have server farms handling the request, and the requests are getting load balanced, distributed, right? I think Asela gave it as an example of decentralized because it looks like there's no single server handling all the requests. There are multiple servers handling all the requests. So then it must be decentralized, right? So that's where most of us make this mistake. So we think centralized should always mean a single machine, but it's really not. As long as you have some coordination point, that system is called a centralized system. Because in this case, all the requests has to flow through the load balancer. So you have a single point of control, okay, even though there are many replicas of the server. So again, going back to the classroom example, so these servers can be considered as the kids in the room, okay. So you need someone to make the kids behave well and get something useful out of them. You need a coordinator like the load balancer, okay. Right, there's another example. I think some of our projects people would know this. So in this case, all the servers were replicas, right? Server 1, 2, and 3, we can consider them as replicas. But there is a situation where in technologies like Cosmos DB, you would have different partitions behind the scenes holding different sets of data based on the partition key. Okay, I mean, some people won't know about this, but people who have worked with NoSQL databases or Cosmos DB would know about this. So Cosmos DB as a whole, it's a database, but internally he maintains partitions storing different sets of data. Now, when a request comes in, it has to decide from which partition should the query be executed, or which partition should this particular data be stored. Okay, so in this case, again, partitions are like the kids. You need some form of coordinator um, to direct requests and get something useful out of these partitions. So he has to, there must be some server sitting in front of these partitions to coordinate these requests. Okay. So far, is it clear the concept of a centralized system? So centralized doesn't mean single machine. It will actually be many machines, but there will be single points of decision making along the way. Okay. Any questions, guys? Okay. So seems like everyone understand it's perfectly clear. Awesome. So let's look at the nature of this coordinator. So we kept using the word coordinator. Now, so coordinator essentially means there's a single point of control, or some people call it an authority. So in the classroom, teacher is the authority. In a centralized system, the coordinating server is the authority. Everyone honors. I heard some. I think someone came in, right? So in a centralized system, centralized means there is a single point of control, and the coordinator is handling or coordinating activities going through the system, right? Now, in the case of the classroom, it's the teacher doing the coordination work to make the students behave well. Now, in the real world, like the classroom example, in the teacher's case, it was a single human being, right? Now, if you take something like, let's say the government, okay? So the government coordinates the country, okay? I mean, at least the government is supposed to coordinate the country, but I mean, not that our present and past governments have done it well, but they are supposed to coordinate the country well, right? But is the government, I mean, we see the government as a single entity, right? The government, the big government. But is it a single person? No, right? So it consists of many institutions and many people, many branches. There's the legal system, there's the, I don't know, parliamentary system, there's the government. So there's that bureaucracy concepts, right? So it's not a single, even though we see it as a one big single entity, it's actually a collection of multiple entities inside it, right? But still we call it the single authority for our country, right? So just like that, even in IT systems, having a coordinator in this diagram doesn't mean this is a single machine, okay? So when we use the term single, as traditional IT people, we are used to thinking single means singleton, single machine, single point of failure. So those are very common terms for us, right? So we automatically tend to assume it's a single machine. So if something happens to this is always one machine. So if that fails, everything fails. So, but single point of control doesn't mean single machine controlling it. It can be a fleet of machines like this. Multiple machines working together to perform the coordination job. Okay, just like the government. Okay, or just like let's say a committee, a society which is governed by a committee. Okay, without a president. Okay, so all the committee members have almost equal powers. Okay, um, but still, even in the real world, and even with this kind of fault tolerant coordinators, you would find there's a form of leaders. Okay, so even in the committee there would be a head of committee. Okay, I mean, the whole point of the committee having a committee is if one person falls sick, then still there are some other people remaining to look after the coordination job, right? So this fault tolerant coordinator, when there are multiple machines, if some machines go down, still there are other machines there to take on the coordinator job. Okay, so can anyone explain how this fault tolerant coordinator would work? I mean, would they all be equal all the time? What would happen here? I mean, how would they work together to perform the coordination job? Any ideas? Any thinking you can do?
Yeah, they'll communicate with each other and do the coordination, like I will take care of this part and you will take care of this part, something like that.
Yes, yes. So it can be something like that. So they have to store within this fleet of servers. They still have to do some pre-agreement or coordination work to assign jobs to themselves. Okay, I do this, you do this. Or in some systems there are leaders. So in such systems, leader performs all the work. Okay, if for some reason leader gets sick, leader goes down, then other people will elect a new leader. Okay, automatically. Probably in IT systems we use timeouts, right? So if for a while the existing leader hasn't performed any job, then we detect it using a timeout. Then the remaining servers will coordinate amongst themselves and elect a new leader. Okay. Now Savinder's example was sort of like having multiple leaders for different areas. Okay. Still, if one leader of one area goes down, then someone else has to take control of that particular area of the system, right? So that's the point of a fault tolerant coordinator, and that's how most real world systems would function. So if I take that Cosmos DB example, now Microsoft doesn't have a single machine listening to the request. So they would have a fleet of servers deployed around the world doing this coordination job. So if any of their data centers goes down, whatever, some other country's server can take over the job. Okay. I think we did some Kubernetes. I think I'm not sure whether something is about to come up. I think Kubernetes. So I think even in Kubernetes, you will hear there are things like master nodes. So there at any given time there will only be one master node, but if the master node goes down, someone else will become the master. Okay, so that's people trying to take over the coordination job. So at any given time there will only be a single coordinator. Okay. Right.
Question.
Sorry.
So is that, now say if you take coordinators, is there any, I'm not sure like how like it might depend on system. So coordinating coordinators. So it's going to be like a tree, right? It will go down based on the complexity of the system and
Exactly. Yes. So in complex systems, there will be multiple coordinators, and there might be coordinators coordinating coordinators, right?
Yeah.
So even in durable functions, you can have multiple orchestrator functions, one orchestrator function triggering another orchestrator, and then it triggering it can go like a chain or a tree hierarchy, right? So it can happen, certainly. And I think it is the case in most of the systems that we do as well. Now, if you take a common system, when the moment you use Cosmos DB, your requests are going through the Cosmos DB coordinator, right? Even though we don't see it. And when you want to do asynchronous messaging, you are using the service bus service, which is another coordinator, right? Which is coordinating your other microservices basically. But what's the root coordinator? Probably your front end API, probably, right? So so you have your own coordinator which is distributing the work to other coordinators from Microsoft, something like that. So yes, so I think those are the real world examples. But even though there are many systems involved, still we can't say it's decentralized because there are these kinds of coordination points. Okay, any other questions or observations like that? I mean, someone can say, I did the system like this, but I think it's decentralized or it doesn't have a coordinator. I would be really interested to hear such an example and try and point out, no, this is the actual coordinator, you actually had the coordinator. Do you have any examples to challenge me like that? I mean, I get in trouble when trying to do knowledge transfers to the new team members sometimes. No? Okay, yeah, it's good. It's good. So we'll move on. So another, I mean, we were discussing the properties of these coordinators. So nature of these coordinators, I hope you can hear me well. It's raining a bit heavily. Um, so So another property of this is the entire system has to be set up with agreement of all the, let's say, administrators, right? I mean, two completely unknown people with no communication whatsoever cannot set up a centralized system together. Okay, so I mean, in our project's case, I mean, it would be the project team who would set up the database server and then configure the web server to talk to the database connection string. So there has to be coordinated work. So even though the database server itself might be hosted from Microsoft, we configure it, right? So there will be coordination work between ourselves and Microsoft as well. Basically, we tell the Microsoft, use this SQL Server port, use this password, use this user account for the SQL Server, like that. So there always has to be a coordination among the system setup people as well. Okay, even if you, let's say you do a big system with the collaboration of multiple companies. Okay, there are systems like this. Maybe you might do a IT system for the government. So some servers are in the government. So you might not even meet those people, but still there has to be communication, email communication. Hey, my server's port number is this. You configure your outgoing connection string to this particular port number, password, whatever, right? So even though we might not know them personally, still we will coordinate with the other teams. Um, so that's another property or a requirement of coordinators. Okay, because the coordinators has to know about the things that they have to coordinate, the things that they have to coordinate, and sometimes those things has to know about you will be coordinated by this coordinator. Okay, going back to the school's example, teacher will have to know who's on the register, right? Who are the kids in my class. Otherwise, teacher won't have any guidance on who are the kids in this class. Maybe someone else has sneaked into the class to do some shady thing, right? and the kids themselves has to know this is your teacher. Like sometimes in the school, the principal would tell the kids, okay, kids, for this year, Mrs. Samaranayaka will be your class teacher for this year. Please welcome her, say Ayubowan, and everyone gets to know each other. So there's that coordination work that has to happen initially, and then the system can keep going. Okay. I mean, these are obvious things. Okay, I'm just stating the obvious because we have been working with these centralized systems for so long. All this is obvious to us. I'm just saying it out loud. Okay. And different nodes, meaning different points in this diagram. So the different nodes or different servers will run different kinds of software. Okay, so your web server will run IIS and your ASP.NET application, and the database server will run SQL server, right? In this case, coordinator would be the web server, which should coordinate the request and then direct some requests to the database server likewise. Okay, so there are different servers, and again, when setting up, there has to be a coordinated work in which server we are going to install SQL server, in which server we are going to install service bus or IIS. Okay, so that's another property of centralized systems, and when you have coordinators. Okay, and they would also hold different pieces of data as well, right? I mean, web server would not have the user records. User records will be in the database. So the images or some big files, they will be in the blob storage, likewise. So how about P2P? I mean, this is one question I sort of half expected that someone might ask, but I mentioned it in the slide. So P2P networks, what do you know about P2P networks? Do you use P2P networks? Hands up, or I mean, just say it out loud if anyone is using P2P networks.
Torrent applications.
Yes, exactly. So that's the our favorite one and only P2P application, most probably. So torrents, right? So we call it peer-to-peer networks. BitTorrent protocol, we call it as a peer-to-peer protocol. So can you tell me? Okay, so since Tarindu answered that, I'll catch him by the neck. So is P2P a centralized or decentralized system?
I think it's decentralized.
Okay, why is that?
I mean, I vaguely remember we did something similar in our final year project, like coming up with a some sort of P2P like framework. So I'm not sure if Asanka remembers it. So yeah.
You did the project together?
Yeah. So we
Nice.
were in the same final year project.
Okay, nice.
It
nice
is decentralized, but I can't remember. So each node has its own logic running. So yeah.
Yes. So I think this diagram would even explain what Tarindu and Asanka was trying to do, and this is what happens in the BitTorrent protocol as well. So it's a network which connects people to people, right? So when I download a file, it's not coming from a Google server or any such well-known file server. It might be coming from someone else just like me who is running the BitTorrent software on their machine, right? So I mean, I was also looking at it. So it looks like it's decentralized, but actually it's not. When you get down to the details, it's not. But I think this is a very close example to being a decentralized system because there are almost no coordinators. Okay, but the problem is there are coordinators. That's the problem. Okay, I mean, when we use the BitTorrent software, we will think that files are coming from other people like me, other peers like me. But to initiate that process, they actually need these well-known indexing servers, so lookup servers. So basically, when you host your file so that other people can download it, you have to let these lookup servers know these are like set of well-known servers. I mean, even I can also run a lookup server, yes, but then I have to add that to the global list of probably, I don't know, that basically the BitTorrent software has to be updated so that my lookup server is also included in their default list. So basically, when your BitTorrent software starts, when you say you want to download a particular file, it actually uh, do you see that when you download a torrent file, there are some URLs? I mean, I haven't studied this. Probably Tarindu might know. So there are some URLs like nouns or some things like that. So I think they point to some of these servers. So within the torrent file, it would tell you how to find the lookup servers which contains information of where these files are located, something like that. Okay. So your BitTorrent software would first contact the lookup server and find out the peers who would contain the file. Okay, because not every person has every file, right? uh, I mean, some people might have different set of files, some other people will have different set of files. So you have to find out which nodes has which files. Okay, so when you want to download a song or a movie or something like that, um, that BitTorrent software has to look up these indexing servers to find out where to download the bytes from. Okay, so there is a centralized aspect there. Okay, because the moment you do that, not everyone is running the same software. So there are lookup servers. So basically these are doing the coordination work. Okay, am I correct, Taridu?
Ravin, actually, I can't remember the lookup server bit. Probably, yeah, if that's the case, definitely it's not going to be a decentralized one. So,
Yeah,
yeah.
but I think now there are actual, I don't know, maybe in your university research project, because it was a research project, probably you were trying to implement something really decentralized. I'm not sure, but I think now there are actual decentralized P2P networks as well. But I think BitTorrent is not one of them. So,
Ravin,
so
so we were trying to come up with a framework, not the so P2P applications can be built on top of that. So
right.
like
Okay, okay, okay.
it's just a message passing like framework.
Okay, so it's a different
Decent.
domain, a slightly different domain, right? Not tackling this problem.
Yes.
Okay. I mean, this is not some area that I have knowledge of. It's something that I noticed when I was trying to answer this question. Okay. So, so there could be some things which might seemingly look decentralized, but really not decentralized. Okay. Now, finally, let's look at what the hell is decentralized computing. So all this time I spent a lot of time trying to drill you what is centralized computing. Okay, trying to make you understand what you already know. So what about decentralized computing? So in decentralized computing, there should not be any coordinator in any area of the system, and all the nodes has to be equal. And they are, I mean, all the nodes has to be equal in the sense they all have to run the same software. Okay, the moment you have different software, like then you have to coordinate, okay, which software should I run? The moment you do that, you need to have someone else telling you, you run this software, you run that software. Okay, so you have to have that equality to get rid of the coordinators. Okay, and in order to set up such a network or to change configuration of such a network, uh, you don't need a coordinated team or multiple teams working together. Okay, so for all we know, these 10 or 100 servers might be owned by 100 different people who would never know each other and who would never communicate with each other, but still they can form a decentralized network. Okay, so I'll try to explain this in a banking network example. So in a traditional banking systems, what happens is you have customers and then you have the banking network, which is denoted with the pink box, and you would have some set of web servers on the banking portal, whatever e-banking system, and they would have another fleet of sophisticated servers maintaining the banking database. Okay, let's talk about a single bank. Okay, so if one person says, I want to transfer 100 rupees to another account, the request would flow through the banking network. It would first flow through the web servers, and then it will eventually get validated by the banking web servers, your username, password, your authorization, and it would instruct the database to basically subtract some amount from one record and add this amount to another record. Okay, that's basically it. Okay, so the bank would actually conceptually have one big database. It doesn't mean a single machine. Okay, the database will be hosted by a very set of powerful servers. I think that everyone understands. Now let's look at the decentralized banking system. In a decentralized banking system, there is actually no bank. Okay, so in a centralized banking system, there was a registered bank in the government. Okay, so there is Bank of Ceylon, which is registered in the central bank, whatever. So in a decentralized banking system, there's no such bank, as you can call it. Okay, what we have here is a set of unknown people hosting the same software and the database on their servers. Okay, so this is basically a replica setup. Okay, this is basically like a replica setup without a load balancer, without a coordinator. Okay, everyone runs a copy of the banking software, which has its own database and the banking business logic. Okay, so all the people will have all the accounts. I mean, all the people have the same copy of the database. Okay, there is no leader. All the copies are equal, and if this particular bank has 100,000 accounts, all the database copies will have the 100,000 accounts and all the details. Okay, and if two people wanted to transfer money between themselves, so let's say, I think my example is blue is saying I want to send 100 rupees to green. Okay, so what you would do is, I mean, one thing the blue guy can do is he can simply modify his local copy because it's under his control. Okay, he knows the username password of this server. He has installed the database himself. He knows how to change the records and everything. So he can very easily change the records to any amount he wants. Okay, but in the larger picture, it won't matter because it's like you at home. So you shouting like, I'm rich, I'm rich, I'm rich, I'm rich. No matter how many times you shout it, you don't become rich, right? Unless the rest of the world also believes you are rich. How do they believe it? Rest of the world has also to know that you have this much money in your bank accounts, whatever, right? So this is also the similar case. Just modifying your local copy doesn't matter. All the copies has to be updated with that same modification, and everyone has to agree to do that modification. Okay, so that's the concept of decentralized banking. So what he would do is this is basically his interest. He's expressing his interest. I want to do something like this. Okay, then he would express his interest to the rest of the network. Okay, so this would be basically, some networks would be using gossip algorithms. Okay, and some networks would be using concepts like mining and hashing, proof of work kind of concept, which I'm not going to explain, which I also don't understand that well. And so they all would get to know this particular suggestion. It's like a suggestion. Shall we do this? Like everyone is getting to know, shall we do this? Shall I do this? Is it okay if I do this? Okay, because everyone is running the same software, that software is running the same logic. Okay, So that everyone's machine software would check whether this account A would have a balance of more than 100 sufficient funds, and do some validation checks, do some authorization checks whether actually this who said this message actually has authority to tamper with account A, whether he's the actual owner of account A. They would do some authorization checks, and if they are individually happy, they will modify their individual records. Okay, so as long as everyone is performing in a legitimate manner, and they are all running the correct software version and everything, all the logics will be the same, and the end result would also be the same. Okay, if there are a couple of people here and there trying to do some bad things or running different versions of the software with some buggy logic, their results will be different. Okay, they might end up with different values in the database after this operation is complete. But as long as the majority of the network is running the correct software version and behaving in the same manner, you can form a sort of consensus. So this is somewhat like how our society also works. So even though for certain things we need the coordinator like the government, certain things we have the general set of beliefs, right? So this is a common example I always take out. So everyone agrees that murder is bad, right? I mean, you don't need a government law to mandate that if you kill people, you will go to jail, right? Because I mean, the moral principles that we all live by, we generally agree, right? It's not like it has to be written somewhere for everyone to see, hey, look, these are the rules you have to adhere to. I mean, there are some rules like that, right? I mean, there are always rules to protect the rest of the society from bad people. So those are the odd man out. So there are always one or two people who believes murder is okay, and if I want to kill someone, I should kill that person. Okay, but I mean, as long as that is the minority of the society and the civilization can go forward, right? I mean, as long as most people in the society lives by the same moral principles without having a coordinator, the society can move forward. So this is what the decentralized bank does as well. So in a way, the bank is installed on everyone's servers. Okay, I mean, practically it gets much more complicated than that. There are a lot more moving parts and a lot of more concepts we have to understand. But I mean, as long as everyone agrees to do the same thing and everyone says, yes, this transaction is correct, it's authorized, there are sufficient funds, I did it correctly, so everything checks out, then everyone commits the transaction to the database. Okay. Now, so one thing is in these days, so you see this the moment you see this database icon, the traditional cylinder icon, you think of the SQL server, right? Or Cosmos DB or whatever you already know. But in decentralized computing, there's a form of data storage which is much more secure, which is called the blockchain. Okay, so this is where the blockchain comes in. Blockchain is a specific technology used for some aspects of decentralized applications. Okay, so I'm not going to explain that, but I just gave you that to let you know where that term fits, where that blockchain term fits in this whole decentralized concept. Okay, but to know decentralized computing, you don't have to know blockchain. I mean, you could even implement a decentralized application with just SQL Server as well. Okay, you don't need blockchain, right? But traditionally in the real world, people use blockchain. It's like in traditional banking systems, no one would store the user accounts in a text file, right? No bank would store the user account in a CSV file because it would be considered really bad design. So you would use a secure, sophisticated Oracle or SQL database, right? So likewise, in decentralized systems, the architects would make this choice using a blockchain. Okay. Any questions? I'm a bit doubtful on this part. Hopefully, I don't get swarmed
Ravin,
with questions.
it's on.
Sorry.
It's okay. I'm just asking, like, are they practically a bank using these such decentralized banking systems?
Yes. So there is, I think, I don't know many. I only know one. There's a thing called organization called Ripple. Anuradha did a tech talk on that Ripple blockchain. So they are a decentralized banking system. You can't call it a bank actually. It's a decentralized money transfer system. Okay. So,
Say in case of a failure of one network, so now would that so let's say if one participant down, and if everyone wants to agree in order to accept and update the ledger or whatever the database, in a case of absence of one participant, would it affect the real-time transactions? And I mean, like these days, fast money transfer, people expect to be happen quickly.
no. So what will happen is all the nodes try to adhere to the same rules. So as long as 80% of the I think in the Ripple network, as long as the 80% of the participants are alive, they can proceed. Transactions can proceed.
Okay. And also, even though this is said decentralized, still there has to be, because no one can, like just enter to the system, isn't it? Like no one can just open a node. Has to be basically, I don't know, accepted and honored by everyone else, and
Exactly.
welcome to the club, isn't it?
Yes.
So,
And that process is decentralized. That's the thing. So when you join a society, that's a really good example here. Ran. So when you welcome to the club example, okay. So when you join a club, who will have to approve you? You will have to pay a membership fee to someone, either to the president or treasurer, and get a payment slip, and that's how you become a club member, right? But I think there are human societies like this following this decentralization concept, where although majority of the members has to accept you as a new member. Okay, you don't have to convince a president or make a payment to the treasurer, which you can bribe. Okay, or if the treasurer is an enemy of yours, he will reject you. Okay, so that's the bad thing of singular coordinator. So the moment you give that responsibility to the rest of the society, the larger society, then there are a lot more people you have to convince. Okay, so basically if I want to join the network, I would, it's like sort of like I would submit a proposal. Hey, can I join? Okay, then there are actually protocols for that. So you have to prove yourself for a continuous 1 or 2 months. You have to run your software and prove that you are uh, living by everyone else's rules. Okay, I think it's how in the older days it's how tribes worked. If someone wanted to join a clan, they have to earn that acceptance from the rest of the clan. Probably not even the clan leader, everyone has to accept him into the clan by living in the clan and showing that you are a good citizen. Okay, but nowadays in government, I mean, as long as you you take your citizenship papers, that's a centralized mechanism, right? So you have to register in the government central citizenship database. So you have to register in that. But in that Ripple decentralized networks, uh, even the joining is also decentralized, and even the rules themselves can be changed by decentralized voting.
okay.
Okay, so I mean, let's not go there. Let's not go there. Otherwise, we'll take too much time, and there are some things that even I also don't understand that well. But you asked a really valid question. But know that every process is decentralized in the decentralized systems.
Thanks.
Okay, cool. Any other questions? I think I have one more slide. Cool. All right. So you might see. So I mean, this is. I'm not trying to say this is decentralized computing is better than centralized computing. It's a different philosophy. Okay. So there are strengths and weaknesses. So one notable thing in decentralized systems is they use cryptographic authentication rather than username password authentication. Okay. So the moment you have username password authentication, uh, So you need to have a coordinator to reset your password. Then the central system becomes the custodian of your user account, right? That's the case with the banking system as well. They would initially assign you a password, and then you would reset your password. They would create your user account. You have to convince them, I am a worthy customer, right, to open an account. So and if you forget your password, they can reset it for you. You have to convince, I am Hiran, I am Ravin, please reset my password. So, but in the decentralized systems, there's almost always cryptographic authentication, meaning, I'm not going to talk about this. So there are digital signatures and encryption to prove your ownership. And instead of the password, you would hold the private key, which you would not share with anyone, which you would not upload to the network. Okay. And I explained the second point earlier. So normally as data storage, these systems would use cryptographic ledgers, which is the blockchain. Okay. And the third point, which can even, some people might consider this as a weakness, some people might consider this as a strength. Now, in the banking system, in a traditional banking, let's say BOC banking system, if you forget your password, will you lose access to your money forever? Can someone answer? Okay, let's.
No.
Yeah, because I mean, you can talk it out with the bank, right? පොඩ්ඩක් අර කතා කරලා ගොඩ දාගන්න පුළුවන් නේ. So you can convince the bank, hey, I lost my password here. Here's my identity card. Here's my personal information. You can prove your identity, and they will reset the password for you. But in the decentralized, in the previous decentralized banking example, your authentication key is your private key. There's no human identity to that. If you lose that, God bless you. You will lose your funds forever because you can't reason with math. Okay. Only mathematics can save you, and mathematics can't save you if you don't have that cryptographic key. Okay. So you can't argue with math. You can't prove by showing documents to mathematics. Okay. So in the case of authority, you can convince that authority to reset your password and enable access to your funds, right? But the same way, when there is authority, someone can bribe the authority as well, which is the case with the government, right? So anyone can bribe the government or parliament members and do whatever they want, right? So that's the argument against central authority. But in traditional systems, I mean, I feel like for day-to-day people, this private key management, I mean, if you lose it, no one can help you. Okay. And there are privacy concerns as well. So in the case of earlier decentralized banking example, because the database is replicated on all the nodes, this is all public information. Okay. There's no authority holding, no, you can't see the records, because the whole point of a decentralized system is anyone can verify these records and see whether all these servers are holding the same records even. So all these records are public. Okay. But don't think it holds your human names. Why people can get away with this is, even though the records are public, the records will not hold your human identifiers. The banking system records in the decentralized bank, the records will hold a public key, which is sort of like a GUID. Okay. And only you can access that GUID because only you have the cryptographic private key within your possession. Okay. I mean, I won't try to explain. So don't think that this database says Hiran Amarasinghe 10 million rupees in his bank account. Then IRS, IRD and Hiran's friends will see, Hiran is rich. I should ask some money from him. Okay, so that would be a big trouble. So, but still, there are some applications where it's not useful to decentralize and make the information public. Again, people come up with encryption mechanisms to encrypt the data. So even if the data is visible to the public, it's encrypted. So you can't see inside the data. So there are mechanisms like that as well. Okay, I think we are right on time. So 2 minutes passed. So that's the end of my presentation, Tech Talk. Hope you learned something out of it, but I can answer probably one question if you have, because we have run out of time. Okay, cool. Let's stop then.